So yesterday's arithmetic sequences, I think after you got the hang of it, got a little easy. So I'm going to teach you another type of sequence called the geometric sequence. It kind of shares the same type of pattern as the arithmetic, because remember, back to what makes it arithmetic. Arithmetic means plus 2, plus 2, plus 2, plus 2, all the way through, right? It has to be plus or minus all the way through. If the pattern changes at all, well, then it's not arithmetic. Now, if you guys notice this geometric sequence, it goes from 2 to 10. So, like, we're trying to check if it's arithmetic, we would say that's plus 8, right? But then it goes from 10 to 50. Now that's plus 40. So automatically it's not arithmetic. So the next thing we have to check if it's geometric. A geometric series is almost like arithmetic, except instead of adding by the same number every time, it's going to be multiplied by the same number every time. And that's in the definition right here. It says multiply by the same number each time. That number is called the common ratio. Yesterday when we did arithmetic, it was called the common difference. This one's called the common ratio. Ratios, they're basically fractions. And I know that, like, this question right here, see r is equal to 5. 5 is not a fraction, but I mean, it could be written as a fraction. If you put it over 1, it is a fraction technically. So, I mean, that's about it. Geometric sequences have their own formulas, but testing to see if they're geometric is done the same exact way as we did with arithmetic. You guys remember yesterday with arithmetic? If I wanted to find the common difference, I would do the right one minus the left one. It's the same thing here, except instead of subtraction, well, actually they did it for us. They did it for us right here. Instead of subtraction, you just use division. That's how you find the common ratio every time. This far? Yeah. Okay. Right. Abby, they want your ISS. Okay, so what I was saying was it's the same pattern as before. You got to put the right one on top of the left one. So if you notice this first pair right here, the first and the second term, you put the right one on top of the left one and you divide them and it gives you 5. And you scoot over and you try the next two. 50 divided by 10 still gives you 5. And then 250 divided by 50 still gives you 5. So since it gives you 5 throughout the entire sequence, that means the common ratio is 5. So I'm going to pause this for a second, and I'm going to have you guys determine if it's a geometric sequence, just like we did yesterday. And if it is, find the common ratio. So I'm going to give you, let's see, there's 6 of them. I'm going to give you about 4 minutes to determine which ones are geometric sequences. So guys, let me just say this. Determining if it's a geometric sequence, it's not a guessing game. And if you have to find r, that's not a guessing game either. This is all you have to do. You've got all of your terms right here, and the term is infinite. It's got the 3 dots at the end. You're going to take the right one and put it on top of the left one and simplify that. Then you're going to take another pair, the right one. Oh, God. Where'd it go? Oh, I wrote on the edge. That's why. So you're putting the 6 on top of the -1, then you're checking the -36 on top of the 6, and then you're checking the 216 on top of the -36. If these all divide to the same exact thing, then it's geometric. So the first one, I think it is geometric, right? And r is -6. How about the one below it? Well, this is not geometric because as soon as you put the 16 on top of the 4, that gives you 4. But when you put 36 on top of 16, that's not 4. It has to be the same number all the way through. So that one's not geometric. How about the bottom one? Number 5, yeah. Okay, so this one's yes. And the answer for R is 2. How about number 2 over here on the right side? No. This one's not. Number 4? And what's R? Okay. And then number 6? Yes again. And I think it's -5. Okay. Oh, R equals. So this is, for this entire chapter, these are the only two types that we're going to deal with. We're either going to do an arithmetic or a geometric. Now, it is possible to have neither. If you try to check to see if they're adding by the same amount and it changes, then you check to see if it's geometric. You try to see if they're multiplying by the same amount, and if that doesn't work, well, then it's neither. So you have three options. It's either arithmetic, geometric, or it's neither. And I recommend checking them in that order. Okay, next page. Every sequence has an explicit formula. And we're probably not going to do every single example here. We'll probably just do one of them because they're all kind of done the same. Maybe we'll do two. We'll do number 8. So it says, given the explicit formula for a geometric sequence, find the first 5 terms, and then also find the 8th term. So this is all calculator work. A1, A2, A3, A4, and A5. So the formula says 2 times 1/4 to the n minus 1. So if I'm putting a 1 here, I have 1 minus 1 up here. And guys, for that first one, you'll never need the calculator. 1 take away 1 is 0, right? What is anything to the 0 power? Yeah, so basically the 1/4 goes away, so the answer is 2. I'm going to tell you a huge secret. The number right here in the front, that's always the first term. So we never have to do math for the first one. Second one, you might want to. So you have 2 times the 1/4, and then you have 2 minus 1. Now guys, the reason why it's 2 minus 1 is because we're on the second term. That little 2 right there, that's the n, so we put it right here also. So I think that answer, is it 1/2? Okay, the next one, 2 times 1/4, and we're on 3 now, so I put 3 minus 1. 1/8. And then the next one is 2 times 1/4, 4 minus 1. 1/32. And the last one is 2 times 1/4, 5 minus 1. One over, what is it? 100 and, we do a decimal? Oh. 128? So there's your first 5 terms, and now we need to find the 8th term. So we can jump directly to the 8th term. So we have 2 times 1/4 to the 8 minus 1. I don't know that one. It's going to be 1 over something, I'll tell you that much. 1,192? 8,000. Oh, 8,192. Yep, that's it. So guys, if you look at the pattern here, the pattern is just divide by 4 every single time. Now, you might not see it, but divide by 4 is the same as multiplying by 1/4. And that right there is in the formula. So when you have that 1/4 there, it means divide by 4. Did you guys understand what I just said? Yeah. So like instead of divide by 2, we don't write divide by 2, we write times 1/2. So that's the catch to the geometric stuff. When you need it to divide, it's just going to be a fraction. And whatever you need to divide it by, that number just goes on the bottom of the fraction. I don't really want to do a second one of those because that's a lot of writing. So we'll move on. Okay, this is the formula to find the nth term, which is basically the same as the explicit formula. The a sub 1 means the first term, the r is the common ratio, and then the n is whatever number you're trying to plug in. So it says, find the 9th term of the following geometric sequence. So first, I know the first term. They always give it to me. A1 equals 1. I don't know r, though. What's r in this example? It's going to be 3. And I don't have to test it because they tell me they're geometric sequences. So I know for a fact they're going to work all the way through. So now that I have that, I can plug it into the formula so that I can find the 9th term. So that means we're doing n equals 9. So a sub 9 equals the first term times the common ratio, and then 9 minus 1. It's going to be a pretty big number. At least 100. Read it off to me. 6,000. Whoa, I don't know what I was going to write there. 6,561. So I was right. It was at least 100. Pretty straightforward. Let's do one that has the fraction in it. Yeah, look at those. So I know a sub 1 is 1/16. I know we're going to find the 9th number, so n equals 9. How do we find r? Do what? It's multiplying by 2. How do you know that? There is a way to always get the right answer. Remember the right on top of the left? Take the right one and put on top of the left one. So in your calculator, pick one of the ones. I don't care which one you pick. I know they're all going to be the same because they said above it's geometric, so it's going to work no matter what. So pick any of them. 1/4. Put it on top of the one that's to the left of it. If you type that in your calculator, yeah, it's going to be 2. So now we just plug all this stuff into the formula. So we want to find the 9th term. So a sub 9 is equal to the first term, 1/16, times the common ratio, and then 9 take away 1. Yeah, final answer is 16. So let me give you a heads up of what's coming next. In this chapter, you're supposed to know how to find specific numbers in these lists. That's what this is. Find the 9th number. You're supposed to know the 2 different types. So you need to know how to find the arithmetic sequence and a geometric sequence. You need to be able to find a specific number within the list. You need to know how to find the common difference, common ratio. And then what's coming up is I'm going to start teaching you how to find the sum of the numbers. So sum means to add them up. So like I could say, find the sum of the first 10 terms of this sequence. So there's, and guys, this whole chapter is all just formulas. So as long as you understand like what the notation and the formulas mean, this is going to be a pretty easy chapter, I think. As long as you can do the formulas. Because all of it's done in the calculator anyways. So I don't see that being a very big issue. That's it. That's geometric sequence. So make sure when you guys are doing the assignments, Also do the review questions. There are some built-in review questions in the back on every single assignment right now because we're getting close to the end of the semester. That way we can start reviewing for the CRT and AZ Merit. Because that covers everything all the way back to chapter 1.